Algebra Geometry 3 classes, once again, good morning, good afternoon, or good evening. We're actually going to get started into the final section we are going to cover here for this year, and that is section 10.2. There's probably going to be a lot of similarities to what you saw in 10.1 actually. It's basically just going to be a matter of having two fractions to work with instead of just one when we work with multiplying rational expressions. So when you multiply rational expressions, it's just like if you're multiplying rational numbers, meaning fractions. You multiply the numerators together to get the numerator. You multiply the denominator together to get the denominator. You can cancel out common factors. You do have to factor first. You can only cancel if the numbers or quantities are being multiplied. One thing that is sometimes an issue, you do not need to get a common denominator, and then we will again ask you to list excluded values. So just to kind of talk through some things here with some just numbers to start. Well, if I have 2 times 3, or 2/5 times 3/4, well, again, multiply numerators together. 2 times 3 is 6. 5 times 4 is 20. And then from there, we will reduce. Well, what will both 6 and 20 reduce by? Well, 6 and 20 both reduce by 2. 6 divided by 2 is 3. 20 divided by 2 is 10. Now, the reason why there is an or listed over here, if you're working with numbers, there is certainly another option, and that is if you see something you can reduce before you start, you can do that. The 2 and the 4. Well, if I wanted, I can reduce 2 divided by 2 is 1. Also divide the 4 by 2 is 2. Then when I multiply across, 1 times 3 is 3. 5 times 2 is 10. So you can see, one way or the other, I have to reduce. Whether you reduce at the end or whether you reduce at the beginning, you get the same answer. Now, for example 2, one of the things you'll notice, we are back to listing excluded values. Well, for these, when there is not any addition or subtraction, it's actually a little easier. You can just say, well, since there's a 5y, y can't equal 0, 36x squared, x also can't equal 0. Now, from here, again, we're just going to multiply across. Now, here is where it's kind of up to you. I actually would say you might find it easier if you try and reduce things number-wise before you even start. So like the 20 and the 5. Well, those both divide by 5, so that'll be a 1. This will be a 4. The 12 and the 36 actually both reduce by 12. 12 divided by 12 is 1. The 36, when I divide by 12, that is 3. I don't have a lot of room in front, so I'm just going to put that there. So now, when I multiply, 1 times 4 is 4. There's an x and a y squared that I can carry over. Then for my denominator, 1 times 3 is 3. There is an x squared and a y. Now, as far as what we can do from here, when you're dividing, remember, we subtract exponents. So I am going to leave the 4 and the 3. 1 minus 2 is x to the negative 1. 2 minus 1 is y. And so then our final answer is 4. The y stays on the top. 3, the x moves to the bottom because of the negative exponent. So that is example 2. Now, for example 3, there are a couple of things we have to worry about first, and that is excluded values. Going back to 10.1, if you remember, for the excluded values, you set each numerator or denominator quantity equal to 0 and solve. Well, subtract the 2. Negative 2 is one excluded value. Add the 2 here. Positive 2 is the other excluded value. Now, from here, what we can do is cancel an x plus 2. As long as, again, the addition or subtraction quantities are the same, we can cancel those out. Now, as far as what's left in my numerator, 12x. Now, for your denominator, do not actually distribute. That's one of the things that you will see you don't need to do. You actually create more work for yourself if you do. All I now have to do to finish is reduce my 12 and 8. 4 divides into both of these. When I take 12 divided by 4, that leaves 3x. When I take 8 divided by 4, that leaves 2 and x minus 2. This is your final answer here. I cannot reduce the x and the x minus 2 because that is a quantity. So those are the first few examples if you did print off the notes. Now, sometimes you are going to have to factor before you actually do any other work. Here's an example of one of these now. For the n minus 2 over 6, there is nothing I need to factor there. I am going to have to factor the denominator of n squared minus 2n. When there are only 2 terms, this means there is a GCF. I am able to factor n out of both. If I factor or divide an n out of n squared, it leaves n. If I divide an n out of minus 2n, it leaves minus 2. So, first, as far as our restrictions or excluded values, n equals 0, so that means the first one without any work at all is 0. Then n minus 2 equals 0, add the 2. The other excluded value is 2. Now, as far as what happens with this one, I have an n minus 2 in both numerator and denominator, so I can get rid of those. And that leaves 3 over 6n. Now, my final step here is I am going to be able to reduce 3 and 6 both reduce by 3. 3 divided by 3 leaves me a 1 in the numerator. 6 divided by 3 leaves a 2n in the denominator. So that is that one. Now, example 5 has a couple of different things that are going to show up. First, my denominator of a squared minus 4. There is not a GCF. When you have something like an a squared minus 4, if you remember that is a difference of squares. The square root of a squared is a. The square root of 4 is 2. So my two factors are a minus and a plus 2. Now I am going to go ahead and just write this one out. Good news is, second fraction does not have anything you can factor. Now, before we worry about this numerator, I am going to now come back and get all of our restrictions. This one is actually going to have 3 of them because I have 3 different quantities. For this one, add 2. For this one, subtract 2. And for this one, subtract 3. So, our 3 restrictions, and it doesn't matter what order you list them in, 2, -2, and -3. Now, for my numerator here, a squared plus 6a plus 9. Again, this is where we are going to have to factor. We have to find what multiplies to 9 and adds to 6. Well, our only options to multiply to 9 are 1 and 9 or 3 and 3. Well, in terms of what adds to 6, 3 and 3. So, my numerator will be a plus 3 and a plus 3. So from here, now it's a matter of what can we cancel or reduce. I have an a plus 3 in my denominator. I am able to get rid of one of the a plus 3's in the numerator. If I cancel one in the denominator, I can only cancel one of the numerator terms. We do also have an a minus 2 in numerator and denominator that we can get rid of. As far as what's left, I have an a plus 3 here, an a plus 2 in my denominator, and that is your answer. I am also going to release that first 10.2 Schoology assignment as well. So you can see a lot of similarities with what we just did in 10.1, but the main difference is sometimes now you will have a second fraction that you have to deal with.